Hi, it's John Brown from Mobilize.net. How you doing today? In this video, we're going to explore some basic differences between a Windows desktop app and a web application. Before we dive into that, let's look at how the web came to be in order to better understand the unique needs of applications that run on the web. If this is too basic for you, feel free to skip ahead. I can't imagine living without the web on a daily basis. Google, Amazon, Twitter, Facebook, Reddit are all part of my routine. I subscribe to 2 newspapers, but no paperboy ever throws one on my porch anymore because I only get digital versions. All these and more are possible because of the World Wide Web. But how did that come to be? How exactly did we get to this amazing place where information's available instantly, anytime, day or night? Well, what we know today as the World Wide Web had its genesis decades ago in something called ARPANET, created by the Defense Advanced Research Projects Agency, a sort of U.S. government think tank. The military wanted a computer network that could survive a nuclear attack. As a result, they created the basic structure of what we now think of as the Internet. It actually became the Internet after universities and organizations all over the world were added to the network. A nice English fellow named Tim Berners-Lee figured out that the Internet would be a whole lot more interesting if he would invent the World Wide Web. So he did, and he got knighted for it. Sir Tim had to invent a couple of important improvements to get his World Wide Web thing up and running: HTTP and HTML. HTTP, or Hypertext Transfer Protocol, allows web clients and servers to talk back and forth. If you look at the address bar on a web browser when you connect to a web page, you'll see the address always starts with HTTP or HTTPS. That's simply a directive to the computer on the other end that what follows will be using the Hypertext Transfer Protocol. Let's double-click on HTTP. Hypertext is a way of embedding links and documents to other documents or nodes. It's based on ideas that go back to the 1930s for creating non-linear documents. Transfer means that this is designed to move information, that is, transfer from one computer to another. There are lots of different network protocols, but HTTP was designed from the beginning for document transfers. Protocols are languages that computers can speak to other computers. A protocol is just a set of rules that both sides of a communication can agree to and understand. In this case, HTTP contains a set of verbs, for example, like get or post. HTML, the other invention, is a way to describe documents based on their structure. HTML stands for Hypertext Markup Language. There's hypertext again. Since Sir Tim created a protocol for transferring hypertext documents, it made sense to have a way to create hypertext documents, and thus HTML was created. HTML itself was derived from something called SGML, Standardized Generic Markup Language, which was popular with aerospace companies to create technical manuals. HTML, which we all know is used to code up web pages, was intended only to describe the structure of documents with links, not their formatting. In the 1990s, websites sprang up like mushrooms after a rainstorm, and most of those early websites were pretty ugly. Remember, HTML wasn't designed to format things, it was designed to describe things, and the need for internet commerce required the ability to create pages that could talk to backend services like database and business rules and logic. So you had this gap between the ability to create attractive pages and also pages that could work dynamically. Microsoft responded to the demand for this gap by creating a number of tools, including ASP.NET, which was first released in 2002. It allowed developers to combine server-side code with HTML to create web-based applications that resembled Windows applications, with familiar controls like labels, text boxes, list boxes, and so forth. Jumping from programming business applications in Windows to creating the same or similar apps that can run from a web server could be quite a jump. If you check out the Mobilize blog, you can find some posts that drill down in detail on the differences between a Windows app and a web app. In this video, I want to start by discussing just one of those differences, application state. What do we mean by application state? For the purposes of this video, we can think of application state as the value of all the variables used in the current form a user is working on or processing. Let's look at a simple example. Here's a Windows form application. It takes your name and two numbers and adds them together. Let's try it out. I'll type in my name because I'm a narcissist, a couple of numbers, and click Add. We get a message box that shows the answer. This is not rocket science. Now, when I clear the message box, our application's still running because I haven't explicitly closed or destroyed it in Windows. And we can see the data we entered into the three fields. This data is our application state. Some of the data is basically immutable: the form title, the labels for each of the three text boxes, the text on the button control. Those values can't be changed at runtime. They were set at design time as properties of those controls. The values of the three text boxes I entered, plus the immutable data, all this together is the application state. Because this is a Windows app, that state is persistent. Each bit of data is stored in a memory location that Windows allocated. The memory is private to this application's process, and no other process can access it. If I left this application open and walked away from my computer, never shutting it off, that data would remain in memory, theoretically, forever. So that's how Windows works. How is a web app different? Let's look at a different project in Visual Studio. This is our little Add To application migrated to the web using WebMAP. The architecture on the server side is ASP.NET MVC, that's the backend, and HTML with JavaScript and CSS on the client side, that's the front end. Note we're using the Kendo UI framework for MVVM, Model View, View Model, on the client side as well. There's a lot more code here than we saw in the Windows version, and if you want to learn more about the way WebMAP creates MVC architecture, please see the other video in the link. For now, I want to run the app and see exactly what happens to the data, that is the state, when the app is running. To do this, we'll use a tool that's quite useful in learning about web apps, Fiddler by Telerik. Fiddler monitors the communication between your browser and the servers it's talking to. It's super useful for a variety of different kinds of problem solving, but for now, I just want to focus on what happens with our little Add To application. In order to do that, I'll filter everything else out from my Fiddler UI. Okay, here's our app running in Chrome. Let's enter some data. Looking at our Fiddler log, we can see everything that happened. For example, these green lines here are files like JavaScript libraries that the server downloaded at app startup. These libraries are needed by the Kendo UI framework and by WebMAP to do a lot of the heavy lifting when our app runs. Down here at the bottom, we see an event, a button click. What happens next is that the application state, that is the data the users entered in these fields, is sent back to the server as a serialized JSON object. If you're unfamiliar with JSON, JavaScript object notation, it's just a simple way to send data using HTTP. It's very common in single-page applications like this is. Fiddler will let us examine the JSON that was sent in a human-friendly format. And looking at it, we can see the values that were entered on the form. JavaScript code on the client takes those values and sends them as a stream of data to the server, like this little animation shows. The server then processes that data and sends a response, also a JSON object. One thing that's embedded in the JSON that we haven't talked about is this unique ID. This is a hex value that gets attached to every JSON message to let the server know which application session is sending the data. If you think back on our Windows app, we didn't have anything like this because Windows desktop apps have dedicated private memory and processes. They basically are only supporting a single user, a single session. Web apps, on the other hand, got to share their memory and processes with all the users, that is, sessions, running the app at any given moment. That means managing state from the server side can get pretty complicated, and it does, but that's the subject of a different video. For now, it's enough to know that both WebMAP and ASP.NET take care of keeping track of what state belongs to which session. In this video, we compared the way Windows handles application state with how WebMAP applications handle it. Windows apps have private memory and processes while web apps do not. WebMap apps serialize state information as JSON objects to send to the server, and the server returns updated JSON objects for processing by the client. In future videos, we'll take a look at what happens on both sides of those transactions.